All right, in these examples, we're given 2 points yet again, but we don't have the graph to base our idea off of for the second part that asks us, is this function rising, increasing, falling, decreasing, or is it horizontal or vertical? So we're going to continue to calculate the slope just like we did before. So m equals, I'm going to call this one x1, y1, this one x2, y2, and it doesn't matter which one you choose as the first point. So I need to do 12 minus 4, and then 9 minus 7. Okay, so that's going to be 8 over 2, or 4. So my slope is 4. So that's positive, which means I should expect this thing to rise. Okay, or I would prefer to say it's increasing. Okay. All right, let's continue. So here I have 2 points. Again, I'm going to call this x1, y1, x2, y2. So I need to do y2 minus y1. And then x2 minus x1. So negative minus a negative makes that really plus. And 0 minus 2 is really just negative 2. Negative 2 plus 4 is positive 2 over negative 2, and I get a slope over, of negative 1. So if my slope is negative, I expect this function to be falling, or as I would prefer, decreasing. Okay. Right, and let's go ahead and just quickly graph these 2 points and just show that this is the case. So let's do a real rough sketch. And I think I'm going to make my tick marks go by 2. So this would be 2, 4, 6, for instance. Right, 8, 10. And then same thing, 2, 4, 6, 8, 10, 12. Okay. So the 0.74, so it's going to be 7, 4 right there. And the 0.912. So looks like I got a line. Ooh, that's not a good start. Something like that. Okay. So in fact, that thing is rising, right? All right, let's take a look at this guy. A very brief sketch. This is my X and Y axes. All right, so I need to go 1, 2, 3, 4. That's my biggest number that I have. So X equals 2. So this is 1, 2, just so we know. 2 down 4. And then 0 in the X down 2. Okay, so if we connect those 2 points, ooh, way off. It's not easy to do this on a pad when you don't actually see where you're going to cross the points. So something like that. And that is obviously falling, or what we would say is decreasing, right? If we read from left to right. All right, let's go ahead and take a look at another one here. I have the 0.57 and negative 12.7. So my slope is equal to, I do the y values subtracted. So I'm going to do 7 minus 7. And then the x values subtracted. So negative 12 minus 5. 7 minus 7, I get 0. And as long as I don't get 0 on the bottom, then this whole thing's going to be 0, right? So what does it mean to have a slope of 0? Well, if we quickly scroll back up, right, it tells us slope of 0 means that we have a y equals a constant equation, and it should be horizontal. So let's do a brief sketch. Let's see, I have to go to -12 for x. So let's do 2, 4, 6, 8, 10, 12. Okay, so we're going by twos. And then up 7. Okay, so -12, 7. And then 5. So 2, 4, 5 would be in the middle, 7. Okay. So we see we have a horizontal line. Okay. And the last example here, now you might note that the x values are the same, right? The previous example, the y values were the same. So you could probably guess what's going to happen, right? Use your critical thinking skills. So let's do our slope, right? Y change, 13 minus 8, and then the divide by the change in x, which is -4 minus a -4. So that's going to be 5 on top, and then -4 plus 4, which is 0. And we all should know that we can't divide by 0, right? At least not until we get to calculus, then we start calling it something else. But this is undefined for now. And let's see what that looks like. We sketch. Okay, so let's see. I need my x values to go 4 or -4 for both. And I need to go up to 13. So my line's getting pretty bad there, but you get the idea. So -4, 13 was one of the points, and then -4, 8. 3, 4, 5, 6, 7, 8. Right there. So you see we have a really terrible vertical line that I just drew there. And that has an undefined slope. Okay.